Okay, what we're going to talk about here are what are relations, how do we recognize them, and what are inverses of relations. First off, a relation is really just a set of ordered pairs. It's showing how one set of data is connected to another set of data, what gets paired with what. The inverse is going to undo the relationship. That's the best way to just think about it. It's kind of going backwards. So it's reversing the process. If we normally have ordered pairs of x, y, then the inverse would be the ordered pair y, x. There are different ways we can represent relations, tables, mappings, formulas. Right here I have an example of just a listing of ordered pairs. So this is a relation because it's showing me how two sets of data are related, the x's and then the y's. Find the inverse of it, I simply reverse all of those ordered pairs. So instead of 3 being sent to 1, I have 1 being sent to 3. Instead of -2 going to 4, I now have 4 going to -2. So what was kind of the domain is now the range and vice versa. All right, let's take a look at an example where we have a formula given. This is a familiar one to us, y equals x squared. We can set up an xy table so we can get some ordered pairs to look at. So I'm going to pick some negative x's. I'm going to plug those in, pick some positive x's, plug those in, and see what we come up with. So -2, and if I'm plugging into my formula, x squared, I would get 4. -1, I'd get 1, 0, 1, 1, 1, 2, 4, etc. All right, so we graph that and we get this very familiar upward opening parabola, which is a function because remember, we have that vertical line test that tells us if a graph is a function or not. If I want the inverse, what I'm going to do is, even though I don't have a formula, I can take all these ordered pairs over in our first table and flip them. So now I have 4 with -2, 1 with -1, 0, 0, 1, 1, and 4, 2. Again, I want to see what this looks like as a graph. So I'm going to go ahead and graph all of these. Here's 4, -2, then 1, -1, 0, 0, 1, 1, and finally 4, 2. Connect the dots and I get a very similar shape to the original graph. That's not a coincidence. The graphs of relations and their inverses are always going to have a similar type of shape. Even more than that, though, I want you to notice this red dotted line. That is the line y equals x, 45-degree diagonal through the origin. And what we have here is a reflection. So if we could pick this graph up and fold it on that red dotted line, these two graphs would completely align with one another. That's kind of cool, and that's going to be something we're going to use as a visual test for inverses later on. One other thing I want you to notice here is that this inverse, even though it came from something that was a function, is not a function. Why not? Because I can draw a vertical line and touch that graph more than once. That's also important to note. All right, let's see if I give you a graph. Could you graph the inverse for me? So maybe in the homework you're given this red line as your original graph, and you notice some points here, 6, 4, this would be 4, 3, and this point would be 0, -5. Well, if I'm told to find the inverse, what I'm going to do is flip all of these ordered pairs. So -5, 0, and then 3, 4, and then finally 4, 6. And I join that up. And again, I have a picture that's similar to the original red graph, but obviously it's in a different place. And also, if we fold it along that diagonal green y equals x line, those pictures would align. Picture's a little out of skew because it's not a perfectly square window, but we can see that it is going to pretty much align. Okay?